Hello and welcome to a new video. My name is Herwig and today I'll show you a fast and effective way to compare the product carbon footprint PCF of different plastics with each other. So let us get started. The first thing we do is we go onto the website polymermaterialselection.com. I will link it below, and on this website you will find the section Plastic Selection Tools. So this is where we click on, and then we scroll down. Here you see the plastic selector and polymer material selection tools. And we come then here it is, product carbon footprint versus different properties such as thermal properties we have here. So we have on the right side our different polymers. We have amorphous polymers, semi-crystalline polymers, commodity plastics, engineering plastics. Then here we have the main field. We have always on the left, on the y-axis, the product carbon footprint, and then on the x-axis the property. So in our case it's density, glass transition temperature, heat deflection temperature 1.8 megapascal, and the specific heat capacity. When we scroll down, we see also the PCF versus the ULRTI, relative thermal index. And here we have our selectors. So interesting is the last one, where we can change the product carbon footprint, what to be shown. Let's take example. We want to have minimum 1.6 CO2 equivalent and a maximum of, I put here 3. So I put it here on 3. And now it's updating. And what you can see here, okay, our materials have been now selected. So with a maximum of 3 PCF of 3. So we have polyolefins, we have PET, we have polypropylene, polystyrene, also PVC, and the different properties in comparison. And now I would like to have a material with maximum 3 PCF and a minimum HDT of not 30 but 80, because this is an application requirement. And so I put it here on 80 minimum, and voila, so it's updating. And you see we have now 2 materials, polystyrene general purpose grade and the SCN, which are left, which are fulfilling these 2 requirements of maximum 3 PCF and a HDT of 80 degrees Celsius at 1.8 megapascal. Okay, so and here you can use really this to change and then immediately have a fast access of the different plastics. You can also then share it or download it, so you can make a PDF or the data itself, a PowerPoint, or as a Tableau workbook, or simple as a picture as you want. Okay, so this was the first tool. What you can also calculate is the potential CO2 equivalent savings with plastics. And yeah, let's make an example. We have our current part is out of aluminium, and we want to replace it, metal to plastic replacement. And let's say for that we need glass fiber reinforcement. Let's take a polyamide 6 with 30 weight % glass fiber. And we have 50 tons in the project size, or let's make just 10,000. So then you see here we have a CO2 reduction potential of 18.5% when we replace aluminum with a polyamide 6 glass fiber reinforced. And now I can select here, let's take a polyamide 6 with 30 weight % glass fiber, but the whole material is 100% mechanically recycled. And now you see we have 87%. So we can have even a much bigger impact. So going from 18 to 87. And you can try out different materials here. There are different materials in the beta database, polypropylene, also mechanical recycled, and so on. And I try to add more and more materials also on this. Okay, so to summarize, you can go here to polymermaterialselection.com under plastic selection tools. Then scroll down and you find the product carbon footprint, where you can then select here in the end the minimum product carbon footprint and the maximum what you want, and can also then, depending on the requirements, change the density. You want minimum or a maximum density of only one, or as in our example, heat deflection temperature of 80 degrees C. So this is the one tool, and the other tool is the CO2 equivalent savings potential calculator, which is right below, and where you can also then test it, insert your current material, what you're currently using, and then explore alternative plastics and see what reduction potential, CO2 reduction potential you have. Okay, good. That was it for today. I hope these two tools are helping you to access this PCF in a fast way and compare it. And you can share the data, download it. And I invite you all to try it out. And I would like to thank you and see you in the next video. Bye.